Alright class, we're on our second week of distance learning, yay! So 11.3, we're still going to use formulas, but now what we're going to do is we're using what's called composite figures. In the definition you have here, it talks about it being a figure that's separated into regions that are basic figures, you know, the ones that we've been dealing with: rectangles, triangles, parallelograms, trapezoids, circles, half circles. So pretty much what it is, it's a huge figure that is made up of all those pieces. So the easiest way to do that is to find look at the figure, cut it up into its, into the half circle, into a rectangle, into the parallelogram. Get those areas and then add them together. And that's how you find the area of the whole. As you have here on number 1, you have a composite figure. We have this rectangle, and then we have that trapezoid right there. So you would have to use both of those equations, and those are given to you in 11.1, or starting from 9.1, 11.1, and 11.2. You get the list of all those formulas. Rectangle is just base times height. So you can go with base and height. And this is the rectangle right here. This is this equation. And the trapezoid is right there. Okay, that's 1/2 base 1, base 2. So if it's 23 here, that means that's 23 there. And then you have your second base right there, and then you have your height right here. The rest is just plugging into the area equation. So once you get all that, well, what happens is you have one area, the area of the rectangle, and you have the area of the trapezoid. You add those two together, and you get your final total area of your composite figure. We're doing now number 2. Okay, you notice how we have this circle here, half circle, and we have a half circle here. Both of them are shared, and they both connect to this parallelogram. Okay, so that means that those two half circles is just one full circle. To find the area of a circle, you need to have pi r squared. Oh, guess what the radius is? Right here. That is my radius. Alright? That's also half the side of the parallelogram. For a parallelogram, it's the same. Let me get this erased right here. Base times height. Well, why is it 12? Why is it 12? Because half of the wall is 6. That's your radius for your circle. That means this side has to be 6 too. This is 6, this is 6. Those two together equal 12. And then you have your height. You have the area of the parallelogram plus the area of the full circle, or the two half circles. You get those two together, and you have your total composite figure. If you turn the page, or you go to the next page, page 2 of 11.3, now we're looking at distinguishing between areas of shaded regions using these types of composite figures, or some figures that are within figures. Take, for instance, number 6, right here. For you to be able to take, it's kind of like, let's see, how can I make this an example? Here you have your square, you have a circle inside it. The circle, what you want to know is the shaded area. How much is this right here find the area of that shaded region. Okay, so this is simply subtraction. We're not putting them together, we're actually doing a cutout. Okay, we're cutting that circle out and seeing how much is left. Well, to do that, to find the area of a shaded region, you got to find the area of the full figure. Okay, so in this case, the square. That's the full figure because the circle's inside it. Alright, and then we'll have to find the area of the circle. Once we find the area of the circle, we're going to subtract what's not shaded. Okay, that being the circle. So here we have the area of the square, area of the circle, these two, this guy subtracted. Okay, then we get that. So let's move on to something that's a little bit harder. Let's go on to, let's see, we'll do 7, 8, and 9. We have, let's do 9. Okay. Find the area of the shaded region, which means we have to find the area of this triangle, and we have to find this area right here. So, to do that, we're going to have to find the area of this. That's our empty space. That half circle is an empty space, so we're going to have to get rid of it. We're going to have to subtract it from all of that. Well, luckily, we have our hypotenuse here. We have, this is a right triangle right here, so I can figure out that area. Here's my base. That means I need to find this part. To find this, we can simply use the Pythagorean theorem right here. Okay, solve for 6, and we get x is equal to 15. I apologize, that isn't 6, it's actually b, or the base. Okay, so that wasn't my handwriting. Either way, this ends up being 15 right there. Okay, so how do I get the radius of this so that I can use it for my area of a circle? This is a half circle, so half circle, so I have to put a half right in front of my pi r squared. How do I get my radius? If I know this entire thing is 15, well, I divide that by 2, and that gives me my radius. Last piece. Once you have the area of the triangle, or the actual area of that trapezoid, you subtract the area of the half circle, and you're left with your answer right here. To be honest, I think I like the way they did it better than my approach, which is probably, I don't know if you noticed how I switched it up at the end. They used the trapezoid formula instead of breaking it into both triangle and a rectangle. So the trapezoid formula is 1/2 base 1 plus base 2 times the height. Alright, I'm going to move on to 11.4. If you have any questions, again, message me on the private comments. This assignment, I know it was supposed to be due last Friday. I didn't give it to you because I think you had enough work with the other 2 assignments. So I'm going to have this one due by Friday as well. Thank you to all that have been turning in your projects. Alright, 11.4. This one's can be difficult for some of you. We have to rely on this formula right here. Okay. The area of a regular polygon formula. This one's key, regular. That means that the polygon has all equal sides, okay, all equal angles. So we're going to have to remember how to find the degrees inside the polygon, the n minus 2 times 180, that formula. We're going to have to remember SOHCAHTOA and the Pythagorean theorem, because we're going to be dealing with right triangles, okay? I would suggest just to use SOHCAHTOA because it's a lot easier than remembering the special right triangles, the 30, 60, 90 or the 45, 45, 90 triangles. I suggest just using SOHCAHTOA. Alright, and all your phones are capable of using these trig functions. If you flip your phone to the landscape mode, in other words flat, your calculator will give you the options for all the other functions. Okay? So, that being said, let's zoom in here. Parts for a regular polygon. What you're going to need, okay, is the formula. From the formula, you're going to need to know what the A stands for. The A stands for apothem. Apothem is this guy. He's from the center to the wall. Okay? Center of the polygon to the wall. That's the apothem. We already know what radius is. Okay? Radius is going to be, for a polygon, the radius is going to be from the center to the corner, to the vertice. The next letter we need to know in that formula is the P. The P is the perimeter. And we already know what the perimeter is. The perimeter is adding every single side. Okay? Add them together, that's your perimeter. But you're not always going to have all these distances. So we're going to have to solve for these individually. Okay, so here we go. We have number 1, number 2. Both of these are basic. Alright? So finding the apothem, it's not hard. If we look at number 1, the apothem is already given to us. Remember, the apothem is from the center to the wall. So this is my apothem. That's my A. To find the perimeter, well, I have one of the sides. So, because it's a regular polygon, I know all the sides are 24.2, 24.2. So all I got to do is add those 3 up, and you get 72.6. The rest is simply using the formula. Same thing for number 2. It doesn't matter on the polygon. The polygon is going to be regular, so that means all sides are equal. So if you're given the apothem, and you're given one of the sides, you just have to count the sides. In this case, it is 1, 2, 3, 4, 5, 6, 7, 8. 13.3 times 8 gives you 106.4. Then you simply plug all your information to the area of polygon formula, and you get your answer. Alright, so here are the much harder ones. You have 3, 4. If you notice on your notes, I erased this top part. See, the first thing it asks you to do, and I agree with it, is you're going to create a right triangle drawing, and you're going to select the apothem and the radius. In other words, you're going to select the corner, for instance, right here, and connect it from the center to there. That's your radius. Okay? You're really not going to need the radius unless you're looking for a side. Alright? And then we're looking at, secondly, is you want to, if they give you the apothem, that's great. And luckily for us, they give us the apothem. So they already give us the A. Here is our formula. It's 1/2 A times the perimeter, the apothem. So we have the apothem. Bam. But we need to find the perimeter. Okay? To find the perimeter, though, I need to find out this piece right here. we know, for instance, so it says here, step 2, find the measure of the interior angle. That's this one right here. Simply because I need to know that little bitty angle right here. So, to find this one, we need to know first the sum. That means that if you look on step 2, we're going to have to use this formula. Okay, once we get that sum, we're going to divide by the number of sides. In this case, we're going to divide by 6. Alright, 6 sides. So 6 sides will leave me with 120 degrees. But if I want to know half that piece right there, you simply divide by 2. That gives me 60 degrees. I now have a triangle that I can work with. Okay, so if I were to take that triangle out, here is 60. I need to know that piece. Actually, let's go off to the side over here. Here we have that triangle. Bam, just like that. This is 60, this is 5, and this is what I want to know. So we're going to use, toa. That is what? Opposite. This guy is adjacent. Remember, the long one's always the hypotenuse. So OA, we're using tangent. Tangent of 60 is equal to opposite over adjacent, so it's 5 over x. Remember, when you have the situation here, you simply switch. Okay? So x is going to be equal to 5 over tangent 60. Now if you plug that into your calculator, and your phones will have it. Okay, so once you plug that into the calculator, you're going to get a decimal value of 2.8867. Let's go with 2.89. Alright, so now that you have 2.89, that's just a part of it. That is just this little piece right here, 2.89. If I want the whole thing, I'm going to multiply it times 2, so I have the whole side. That gives me 5.78. If I want to know the perimeter, well, I know it's 6 sides, so it's 6 times 5.78, and now I have my perimeter. Plug those into my formula. This is probably the harder problem, the harder work, just because you're going to have to use a lot of math to figure out your equations, or your apetum, or your perimeter. We go to number 4. First step is to create our right triangle. Okay, luckily for us, they give us the apetum. So there's the apetum. The second thing we need to do is find the perimeter. Okay, so think about the perimeters. I need to find this piece so that I can find this one too. Okay, so we need to do step 2. Alright, we need n minus 2 times 180. So this is 3-sided. We know this is going to be, well, this is an easy one. We already know it's 180 insided. Okay, so this equals 180. And if I divide it by 3 sides, we're going to get 60. Alright, that's this angle right here, 60. If I divide it by 2, then I have my set piece. Here we have x, this is 30, this is 18, and this is my 90 degree. So if I'm going to solve for this piece right here, this is opposite, this is adjacent. So we're going to use tangent again. Tangent of 30 equals to 18 over x. Remember, these two swap. let's plug that into our calculator. In the calculator, we come up with 31.18. That is just one piece of the puzzle. So if this is 31.18, double it, 62.36. The perimeter now is just 3 times one of the sides. We now have the perimeter, we now have the apothem, and you can plug it in so you have your area. So you notice on some of this, like number 5 and number 6, they use SOHCAHTOA just like I've been using. I think using SOHCAHTOA is probably the easier one, rather than you having to remember how to use the special right triangles. If you simply remember sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, or tangent is equal to opposite over adjacent, SOHCAHTOA you should be able to know, or you should be able to use that a lot easier than remembering that, oh, the hypotenuse is double the short leg is square root of 3. So I believe this is a lot easier to remember. If not, you can follow the notes. They're using both. They're using both SOHCAHTOA, or they're using the special right triangles. Okay? If you have any questions, again, post them on the private comments, and I'll be glad to answer them for you.